I will explain about single tuned circuit or single tuned amplifier circuit. Generally, tuned circuits are used for to tune the circuit and receive the our required signal. I'll explain clearly here. For example, in a free space, that is FM radio signals are transmitting from, just assume that 88 megahertz to the frequency range is 108 megahertz frequency. So these are the FM radio frequency transmitting signal. FM radio frequency radio. For example, if you go for 92.7 megahertz signal, so it is transmitting in a free space. Just assume a tuned circuit, either high pass filter or low pass filter. If you take, so just assume uh, it is a tuned circuit, or this is R. Here you can say this is R and this is capacitance, and here the frequency is, that is F equal 1 by 2 pi RC, and the frequencies depends on R and C values, and the reactance from this we can write it as the reactance for the circuit is 1 RC equal 1 by 2 pi FC. Assume that it is a low pass filter circuit, means just assume if the frequency is low frequency, just assume it is zero frequency. 1 by 0 equal, that is infinite impedance. RC equal to infinite impedance while we are applying, that is zero frequency signal. Means the reactance across the capacitance is infinite, means whatever you are giving, so it will available across the output here. Low frequency signals are available. In the same case, RC is equal 1 by frequency. Assume that for high frequency signal 1 by 2 pi into infinite into C. 1 by infinity. Zero impedance. High frequency signal. For high frequency, the impedance across the capacitance is 0. Means it will pass towards ground. This is for low frequency, high frequency signals. So means it is acted as a low pass filter. While giving the low frequency, the impedance is infinite. So means it allows towards output side. While giving high frequency, the impedance is 0. It will allows towards ground. So it is acted as a, that is low pass filter. Just assume it is if the R and C values are equal to the 93.5 frequency. This frequency is 92.7 megahertz. If the frequency of this circuit is 92.7, then it allows towards and output side, and remaining it will blocks. So that is the tuned circuit function. Our required frequency, it allows our required frequency and it will stop the other unwanted frequency signal. That is our user application. Here we can see this, what is tuned circuit means. It requires it, we can select our required frequency. Tuning means selecting. We can select as per our convenience. So depends on the user requirement, we can select, that is called as tuned amplifier. And here the amplifiers are classified into single tuned amplifiers and double tuned amplifiers, staggered tuned amplifiers. Depends on the user applications, we can use different tuned circuits. Finally, by using tuned circuit, we can select our required signals only. Coming to the single tuned amplifier circuit. So single tuned amplifier circuit. So this is the emitter, that is BJT we are using. Also you can use FET also we can use here as an amplifier. Depends on the our requirement you can change here. Here the amplifier function, we know that it amplifies the given input signal. So just assume here, just assumption only I am giving this. This is the image, or else we can take audio signal also, that is 92.7 megahertz signal. Just assumption the input is 92.5, 92.7 megahertz FM radio, and these, that is R1, R2 resistors, and RE and CE, emitter capacitance and emitter resistance, and these are the biasing components to set the Q point. As we know that by using this we can set the Q point to get the output perfectly. So by varying these biasing components we can set the Q point and get the output without any distortion. So this is just assume this is the amplified output, of course, but here the tuned circuit, this is the LNC is the tuned circuit, as I said just now. This is parallel tuned circuit. Of course we can use series tuned circuit is also. As we know that that is amplifier circuit function, we know that that is BJT, bipolar transistor. The function is while giving the input signal, it should be amplified, but using biasing components. Using biasing components we can amplify the given input signal. That is the function for the uh, amplifier. So this tuned circuit here, as I said, that this is the parallel tuned circuit. The frequency is, that is 1 by 25 root LC. If this tuned circuit should be equal to the, that is this 92.7 megahertz frequency, then only it amplifies and transmitting towards that is output side. So in this case, the circuit will reject other unwanted. It will stop other unwanted signals, unwanted frequencies. In this at this stage, it is having more impedance to reject other unwanted frequencies, and when the input signal frequency is equal to the, that is resonant circuit, that is tuned circuit frequency, it will amplifies, the amplifier will amplifies and transmitting towards output side. So that is the tuned circuit function. By varying this LNC values we can tune our, we can select our required frequency. If you want 92.7 frequency, we can select 92.7. Otherwise, if you want 93.5 megahertz frequency, we can select 93.5 megahertz signal. Like this, we can select and amplifies towards output side, and we can get the output without any distortion. So that is the advantage for the tuned circuit. We can select our required frequency and we can stop uh, other unwanted signals. So as I said here, the same thing, it will reject other unwanted and it will allows only our required. And coming to the here, you can see this the same thing. Coming to the advantages, the output level is very good. The signal to noise ratio is very good, and high selectivity it provides, and so minimum power loss, that is one more power loss is very less. That is the advantages. Coming to the applications, so they can use dish and radio signals transmission, TV signals transmission, even in wireless communications and satellite communications. We can use mobile communications. We can use everywhere. The tuner nowadays, the tuner circuits are very important. So that is about single tuned amplifier. If you have a doubt, we can send to me. Thank you.